Hello, algebra students. This is the last example in section 9.2. We're going to do a little bit of an application. You are going to need your graphing calculator, so please grab that at this time. Otherwise, you're not going to really understand the keying sequence that I'm telling you here on the video. All right, let's read the very top application. It says, in the year 2000, the world population was about 6 billion. And it was growing. I want you to circle the word growing and put a plus sign there. Growing means it's positive, it's increasing. And it's growing by 1.21% each year. At this growth rate, the function f of x equals 6 times 1.0121 raised to the x gives the population in billions x years after 2000. Using this model, in about what year does the population reach 7 billion? So if you remember all the way back to example 1, they gave us, numbers for A and B and then said, okay, plug in for X and figure out what you need to find out, okay? Calculate it. Well, this time they're going to give us the Y and we have to find the X. In example 1, they gave us the X and we have to find Y. So we're actually kind of reverse engineering this. It's going to be easier if you have your calculator on you. If you don't, go online at this time and see if you can pull up a calculator either on an iPad or a phone while you're watching the video. Okay, so let's kind of deconstruct this original equation, okay? F of x. Now, f of x is population, okay? So it's in billions. So if you see in your calculator, if you're looking at the table in your calculator for this equation, f of x, the y, is going to be maybe some decimal numbers like 6.1. That means 6.1 billion. Or 2.3 means 2.3 billion. Okay? Not 2.3 people, 2.3 billion people. So there's a difference because they tell you what the increment is, okay? What the unit is that you're measuring. The x in our problem is measuring, again, x in years after the year 2000. Okay, so I'm going to rewrite this original problem and mark x is years, number of years after 2000. Okay. So the problem, that's what the problem tells us. This 6 is the original population count in the year 2000, 6 billion. Instead of writing 6 with a bunch of zeros after it, they just wrote the number 6 and explained to you that that means 6 billion, okay? Now this number, where did this number come from? Because it's population growth, they took 100% and they added 1.21% to it. And so you end up with 101.21%, which they converted into the decimal. If you got to move your decimal back 2 places to change a percent just into a regular number, and there it is. Okay? So remember, anything over 1 indicates population growth. If this number was less than 1, this population is not growing. It is actually declining, decreasing. We're going to lose population. We're going to have a number less than 6 billion. But instead, we're actually looking for a number greater than 6 billion. Okay, so here's where you're going to need your calculator. Get that out, turn it on, and press y equals. Beside y1, I want you to type 6 times 1.0121 raised to the x power. Now get that in there. Once you have that in there, we don't need to see the graph of it. We need to see the table. So I want you to hit second graph and access the table. Okay? Now remember, f of x or y is population. That's what they told us in the problem. F of x means population. So you're going to scroll down your y's until you see the first time it switches to 7 billion. And we're looking for 7 point something, okay? And that's what we're looking for. Now, remember, this is number of years after the year 2000, okay? So as you look at your table, you'll notice on your table when you see X and Y1, you're going to notice that 12 is the very last number that shows 6.9316, okay? The first time we see it switch to 7 billion is at year 13. So if it is 13 years after year 2000, what year is 13 years after year 2000? That's right, 2013. And that's the first time we see the population switch to 7 billion is in 2013. Hopefully that made sense. Please write down your questions if you have any for this. And I want you to try this next one by yourself. It's very similar. Notice that we have a decline. That's normal for cars. As soon as you drive it off the lot, it loses value. So this number being less than 1 is actually no real surprise. And here's the original cost of the car, $12,330. And we want to know, when will the car be worth $2,000? How many years is it going to take for this car to lose value where it's finally going to be $2,000? You're going to do the same thing in your calculator. Plug that in beside Y1, and then access your table and scroll down your Y's until you see the number 2,000. Okay? So let me know if you have questions on this. Good luck, and thank you for listening.